Hi everybody, I'm Tony E, and on today's episode of Today I Was Asked, we're going to discuss how to tell if something has been routed based on policy, that is using Cisco's policy-based routing. I have a lab all ready to go, so let's dive in and take a look. Here on this topology we have three routers. The router on the right, router 1, has a loopback of address of quad 1, and this is going to be our source. And the router 2, the router all the way on the left, is going to be our destination. And it has a loopback of quad 2s. So by default, and we'll get in and take a look at the routing tables, but we're going to source our packets from 1.1.1.1, destined for 2.2.2.2, and we're going to see it go over this link, be forwarded from router 1 to our policy-based router. We're going to see it forwarded on this link over to router 2. I've given the link on the top the address space of 10.10.10.5 on our policy-based router and .6 over here, and I've given on our bottom link 20.20.20.4 with 5 and .6 respectively, just so we can tell them apart. By default, traffic is going to go on the top link, not the bottom link, and what we're going to do is through this lab, we're going to implement policy-based routing here to send traffic on this link. Let's log into the routers and take a look at the routing tables to see how they're going to forward packets by default. Okay, here we are. I've got the three terminals brought up. On the bottom right of the screen, I got router 1. At the top middle, I have our policy-based router, and on the bottom left, I have router number 2, which is going to be our destination. Let's take a look at router 1's show IP interface brief, and let's take a look at its routing table. Here I have only our egress and ingress interface, 10.10.10.1, and our loopback of quad 1. Let's take a look at the routing table. I have our connected networks, our local interface, as well as a single static route. So by default, router 1 is going to send any packets that it doesn't have a route for in its routing table to the next hop value of 10.10.10.2, which is going to reside on our policy-based router, our PBR router. Here we are on the PBR router. Let's take a look at its interfaces. Show IP interface brief. You can see we have two directly connected interfaces. The .2 is on this side. The .5 is upstream, as well as our other interface, fast Ethernet 6/0, is our 20.20.20.4 space indicated here. Now, let's take a look at this routing table, show IP route. You can see we have a static route configured for quad 1, and that's going back to our 10.10.10.1. So from the policy-based router to reach quad 1, we're going to forward it to this interface. We also have the loop a static route of 2.2.2.2, and that's forwarded upstream to 10.10.10.6. This is going to follow our top link here and go up to router 2. We also have our connected interfaces, as well as our other connected interface 20.20.20.4. Okay, no static routes here. No default routes here. So we only know about our connected routes and the two loopbacks. Anything else, we don't know the routing for. Over on router 2, show IP interface brief. You can see we have our two directly connected interfaces. This is our 10 network and our 20 network, as well as our loopback. Now to show the routing table here, this is our directly connected loopback. Here's our 10 interface and connected network. And here's our 20 network and connected interface. And again, here we have a single static default route configured to point to 10.10.10.5, which resides here on our policy-based router using the top link. And just to ensure we have end-to-end connectivity, if I ping 2.2.2.2 source from quad 1, we are successful. And let's do a trace. By running trace route, we went ahead and validate that we're using this link and the top link only to reach the 2.2.2.2 network. So what I'm going to do is I'm going to go ahead and implement policy-based routing on this router. We need three elements for policy-based routing. We need an access list, a route map, and to apply that route map to an interface. Now, policy-based routing is only effective on ingress on an interface. So when you apply the route map to the interface, you apply it with the command IP policy, and you give it the route map name, and it's only applied to packets ingressing that interface, not to anything egressing that interface. That's important to know. Okay, so we're going to go ahead and configure an access list. We're going to specify this source IP address in an access list. In that route map, we're going to say anything that's coming from this source, send it out this our 20 network link, and we're going to apply it to an interface. Let's get into global configuration mode. Access list, we'll do access list number 1, permit host, and we'll just do the single loopback address. That's all we need. If we're just doing a single IP address, that's all we need to configure. We can do this using a standard access list. Now let's begin our route map, and we're just going to do this as simple as possible. We're going to match our access list we just specified, match address 1, and we're going to do set IP next hop 20.20.20.6. That's going to be the interface on our router number 2 going out the 20 interface. Okay? So now we need to apply that route map to an interface. We know this is Fast Ethernet 00. So let's get into interface configuration mode, Fast Ethernet 00. And to apply that, we're doing IP policy, route map, and the route map name. I named it PBR for policy-based routing. You can name it anything you want, and press enter. That's it. Now we've implemented policy-based routing. This video is not a lesson on implementing policy-based routing. As you can see, this is a very simple example. Instead, we want to go ahead and look at all of the ways we can verify and see what the router is telling us about when packets are being routed based on policy. Let's go ahead and initiate our pings again over on router 1. I'm going to ping the same address. The packet did take a different route, and you can see that we missed one here. That is in the case of this link needed to ARP for the next hop address. So no traffic actually traversed this 20 network before me starting this video. So this router did not know the MAC address for this router, and they needed to resolve that. So that's why we lost one ping there. Let's go ahead and do a trace. And again, we're going to source it from our loopback. And you can see here, this trace has different results than the one we did earlier. Now we can see it's getting sent back from router 2 on the our 20 network interface, Fast Ethernet 6/0. Okay, so packets are now leaving router 1, sourced from their loopback 1.1.1.1, being forwarded to the policy-based router. The policy-based router is seeing that on its ingress interface here, Fast 0, and is sending it at the next hop of 20.20.20.6 over here. Router 2 is seeing that packet and is going ahead and forwarding the echo reply back. Now, I wanted to point out, over here on the policy-based router, if we do a show IP route, based on this routing table and the information we have here, nothing should be traversing the 20 network interface. Okay, here we have the same two static networks that we had earlier. And in order to reach 2.2.2.2, which is our destination, we should be going out 10.10.10.6. This was kind of the source of the question that was asked to me. How can you tell from the routing table if something is being routed based on policy? And the answer is you can't, because policy-based routing doesn't use the routing table, right? It's taken to effect as soon as the packet ingresses the interface. We actually need to check the interfaces. So short of checking the running configuration for all of them, there are some show commands we can see where policy-based routing is enabled on the interfaces. So one quick one is show IP policy. And that's going to go ahead and show us every interface and the route map that's applied for policy-based routing. So if we had more than one interface, we were doing policy-based routing on more than one interface, we would see those in the list here. In the case of this list, we have only one interface, and here is our route map. That's a pretty good indicator right there. We could always do show run interface, but you don't want to have to look at the running config. Some other ways to go ahead and verify that policy-based routing is turned on the interface. We can do show IP interface. In this case, I'm going to specify our interface. You can see here we have a lot of show output, 2 pages worth, as a matter of fact. Here's a lot of output. Now in here, it is going to tell us somewhere, I tell you what, let's go up and do include policy. Here we go. Here's our same command, show IP interface, and our interface specified. I'm going to include the lines that include the word policy. There are a couple of extraneous lines here, but what I'm interested in is policy routing is enabled using route map PBR. Perfect. That's exactly what we're looking for. Let's also show the Ceph output for that interface. Show Ceph interface FAF00. And again, here you can see we have a large amount of output there. Just to go ahead and filter through it, let's do include policy and also policy. Okay. Input features for our interface, policy routing. IP policy routing is enabled. IP policy route map is PBR. Okay. Those are 3 quick ways we can use for some show commands to actually show if policy-based routing is enabled on the interface and what is enabled and what route map it's using, other than referencing the running config. Okay, but what about showing the route map and showing the access list? Won't that tell us if we get any hits against our route map or any hits against our access list? So let's do show route map PBR. Okay, we've done trace routes and we've done pings through there. So you can see this is the output of show route map PBR. We're matching our access list number 1. We're setting the next hop value, and here's how many matches, 11 packets. Let's go ahead and initiate a ping again. It's going to be 5 pings. 11 plus 5 should be 16, and here we go, 16 packets. Let's also go ahead and show our access list, access list 1. And you can see here I have 18 matches. And again, that's great, but that's not telling me exactly what's being routed based on policy. It's just telling me how many times it's being hit. In the case of our simple lab here, we only have a single host. It's a pretty good indicator. We know it's getting hit by this host. Or maybe our access list doesn't just specify a single host. Maybe our access list that we're matching on specifies an entire subnet. And you want to find out which hosts within that subnet are actually being routed based on policy. If you're just looking at the access list hits, you won't be able to tell which hosts are actually being routed based on policy. And if you're just looking at the route map match count, you're not actually going to be able to identify which hosts are being routed based on policy. A couple other quick show commands I just wanted to point out that we're not going to see policy-based routing in, but I wanted just to cover them so you know that we can't find it in there. Show IP protocols. I'm not running any protocols here, and you're not going to see policy-based routing there. Also show protocols. It's not going to give us any relevant output there. So I'm actually going to go backwards a little bit, and I'm going to change my access list on my PBR router to actually be a much broader subnet, so it would actually match many hosts. Okay, and the reason I want to do that is because let's say I change my access list, or in production somewhere I'm actually matching on 200 hosts, and I want to find out if a specific host is being routed based on policy. So how do we do that? Right? If they're all being hit, I can't use my route map match counter. I can't use my access list hit counter. I'm going to have to use the debug feature. So let's go ahead and change our access list, and then we'll turn debug on, and we'll send some traffic through so we can identify exactly what host is being routed based on policy. So I'm just going to open up this access list to a full /8-sided notation. All right, this would match anything that has a 1 as the first octet. Let's send our pings through again. Pings are working. Let's do our trace. We're still getting policy routed, but again, we're not seeing any output here. So what we're going to be looking for is debug IP policy. All right, there are a couple of options here. If I use the context-sensitive help with the question mark, you can see we can specify an access list. If you're going to be doing this in production where you're seeing lots of traffic coming across there and you are policy-based routing a lot, this debug can blow up your console. Okay. In this example, we're going to turn it on just to show what the output is. I'm going to run a ping, but I'm only going to do a single. And I'm going to see if I can make this a little wider so we can see the output. Okay, I only sent the one ping through. These are timestamp. It's saying the source came in fast, Ethernet 00, and the destination was 2.2.2.2. It has been policy matched. Here it is again. PBR counted. All right, and this is saying the gateway 20.20.20.6 policy routed. Okay, you could imagine if we were routing based on policy, matching lots of hosts that are sending lots of traffic, this output could be overwhelming in your console. So let's actually create another access list to kind of give you a best practices. We can use the access list feature here. So here I'm going to specify another access list. We'll call it access list 10. I'm going to permit host just my loopback, and I want to turn debug on using that access list. So if I do show debug, we can see policy route debugging is on. Let's turn all debugging off. Debug IP policy, and then our access list number, which is 10. Okay. So this is one way we can go ahead and verify if we were matching a large subnet in our access list, which we are doing here in this example, but we only wanted to see if one particular host was being routed based on policy. I'm going to go ahead and send the same ping through. Excellent. So let's go ahead and create, I'm going to modify this. I'm going to create another loopback on router 1. I'm going to call it 1.1.1.2. I'm going to modify the routes on the PBR router and the router 2 to be able to send traffic back, the same as they are for 1.1.1.1. And I just want to have the ping be successful from one end to the other, but I don't want to see it in here. So I'm going to pause the video, do the new configuration, and I'll bring the video back up to show the results. Okay, everyone, welcome back. I went ahead and made the configuration changes. As you can see here, I've added loopback 1 with 1.1.1.2. It's a /32. On the PBR router in the middle, I went ahead and configured a static route to point back to our router 1, pointing back this way. And no changes were made here. Again, all of the return traffic was based on this static route pointing back to our .5 on the PBR router. Okay, so just to show you we are where we left off, I'm going to go ahead and send the ping to 2.2.2.2, sourcing from our original loopback 1.1.1.1. And we should see some debug output here. Perfect, we are, which means we're getting policy-based routed. Now I'm going to up arrow here on router 1, change it to our new loopback, and I don't want to see the debug up top. The ping was successful. I'm not seeing the debug output. Let's go ahead and do a trace. 2.2.2.2. And you can see this host, 1.1.1.2, is being policy-based routed over the 20 link, but we're not seeing the output over here. Okay, so that just about wraps up this lab. I did want to point out one more thing, something that sort of we haven't touched on. Hopefully, you guys have all seen it here, thinking to yourselves as I've been working through this lab. If I do show IP route, I'm going to bring up the routing table on all 3 of these routers. Okay, does everyone see what's going on here? If I have a default route and it's pointing to 10.10.10.2 that resides here on this interface, I'm being policy-based routed as I come from my 1.1.1.1 or 1.1.1.2, policy-based routed over this link, the bottom link. But when the packet comes to router 2, I already have the routing table up, where is it going to send the return traffic? Well, if it's returning traffic to the destination 1.1.1.1 or 1.1.1.2, that isn't in our routing table. So it's going to use the default route to get back. And the default route is on the 10 interface. So we actually have a little bit of asymmetric routing here. That's not an issue for these routers, but would be an issue if there was a firewall in between and you didn't explicitly permit that. So what's happening here is the traffic sourced from loopback 1 is being forwarded to here. We're doing policy-based routing, dropping it here, and the return traffic is being sent this way and then being forwarded across the link. Hopefully you guys all caught that as well. Remember the very two helpful commands here on the PBR router, show IP policy. That's going to go ahead and tell you what interfaces have policy-based routing turned on and what route map they're using. And also debug IP policy. Remember, if you're doing this more than in a lab environment and more than just one host or something that's sending a lot of traffic, make sure you specify an access list to be able to reduce some of that output on your screen just for best practices. Now, before we go, I wanted to step backwards just a little bit and take off the policy-based routing so we can see all the traffic being forwarded back on the original links, just the 10 network links. So let's do show run interface fast 00. I'll grab this right here. Send our pings again. I guess we can do a trace here and a trace here. And you can see from both sources, 1.1.1.1.2, excuse me, and 1.1.1.1, we're both hitting just the 10 networks. Okay, that just about wraps it up for today. I was asked how to tell if something is being routed based on policy using Cisco's policy-based routing. Thank you, everyone. I'm Tony E with Show IP Interface Brief. Thank you for watching.